Hey everybody, thank you for clicking on this video. I really appreciate your support. If you haven't already subscribed, please consider doing so. So what we're going to do is something a little bit different today, in that we're going to take a project from Electronics Australia. I never heard of them, but I presumed they had some sort of a magazine like we do in North America. Somebody had commented on the THD project that I posted on YouTube. They said, well, hey, why don't you build this circuit from May 1993 and June 1993? It's a two-parter. I said, okay. It's also a noise and distortion meter. So it's going to be a lot of fun to build. That's what we're going to do today. Hang on, we'll get the parts together and we'll bring it right back in. Okay, so I gathered all the parts and I almost have all of them. I just need the TL071. Now there is kind of an equivalent for that 741 IC, but the problem is the TL071 has JFET input, so it's very high impedance in the front end, as opposed to the 741 chip that uses BJT type components. So very low impedance in the front. And the pinout's the same, but like I said, we do need that TL071, which I think I've got a source for. I'm probably going to drive down there today to pick that up. Anyway, getting into the weeds. So as you can see, I've got all the parts shown in front of you. They're all used parts. I had them in my parts bins, and yeah, I'm very fortunate in that respect. I do need a case for this though, so I'll have to buy that too. Anyway, let's move on to the schematic. Okay, so right now I'm showing you the schematic. So at the bottom left-hand corner, that's the oscillator. So that's where we're going to get our pure sine wave from for the actual THD Analyzer. It's a Wien or a Wien oscillator. It uses that light bulb thingy there. And that output of that oscillator then goes to the top right-hand corner. And that's essentially where the notch filter stuff will happen, right? So what it's going to do is it's going to eliminate the actual signal itself. And whatever remains is what we're going to measure. And that portion of the measurement is actually on the top right-hand corner. That's the meter circuit. And of course, at the bottom right-hand corner is the power supply. Look, I don't claim to be an engineer. Maybe at the very best, I'm at a technician level. I like to learn when I've got the circuit complete. I'll go through all the stages, put it on the scope, measure the voltages, etc., and learn that way. There is a really good description of the operation in the actual article. So if you're interested, feel free to go there. I'll put a link in the description of where the magazines are. Anyway, so the next part of the video will be just getting the circuit board done, right? So what I'll do is I'll show you the traces and what I've done to them to actually improve them. Okay, so right now I'm showing you the board from the magazine. So this is what I'm up against when I cut and then paste into an editor the board. So you can clearly see that it's poor quality. There's no way, absolutely no way that I could actually do the total transfer method that way, let alone the photo etching type method. It's just old, right? And not only is like the paper, you can actually see the yellow in the paper, it's the traces themselves. They're not very good. In fact, when I import them into an editor, the edges of the traces are actually blurry. So what I have to do is I actually have to edit them, and that's what I do. So the boards now I'm showing you now are the final versions. Well, maybe not final, because I think I have to reverse the image, but the point is you could see how I've edited them to be crisp and clear, and not only that, but get the yellow out of the paper and bring up the contrast. It's actually quite easy within the program. And I use GIMP. It's a free open source type photo editing program. It's great. If anybody's interested in that, that's probably the first place you should go to, especially since it's free. So what I do is there is a contrast control, a brightness and contrast control. You could do that. And that's what I do. And also there's enhance. There's I think a edge, kind of like an edge detect, but more of a sharpen type tool. And then once I've got that done, then I actually have to go into the traces at the pixel level and clean them up. So for these two boards, you're seeing one right now. That's the main board. I probably spent at least an hour and a half on that board. And then the second board, which I'll show you in a second, is the meter board, and that probably was maybe about an hour. So there is some work involved. It's not like I just take these traces from the magazine and then, you know, put them on a PC board. It's a little bit more detailed than that. So anyway, right now, again, you're looking at the main board. The main board, it's actually, there's two boards in this screenshot that I'm showing you now. It's, I have to cut it. So what I'll do is I'll just do the toner transfer method first, and then I'll put it on one board, and then I'll just cut that section. So the left-hand section there, you can see it's a different board. That's the oscillator board. The magazine recommends you separate them, and that's what we're going to do, just to keep, you know, all the spurious noises that are around your lab or wherever you're using this thing don't mess things up. And the next board that you're looking at is the meter board. So that board will actually attach to the meter. My meter is a little bit bigger, but I think I could still fit it on that board. Anyway, so that's the board. So the next part of the video, I'm going to get into the actual toner transfer method and then the etching. Okay, just a quick update. I am running the boards. In fact, I got two already done through the laminator. And then after that, I'll take off the paper and I'll show you what we got. So the boards are out of the water. So if you don't know, after the lamination, I have to put the boards in the water so I can get the paper off. And normally the plastic from the laser printer, it sticks, and those are the traces that you see. So unfortunately, the paper that I use, it's from Staples, but it's very glossy, but it's kind of hard to get the paper off. So you have to kind of rub it with your thumb while it's in the water. But anyway, the boards are out and they look pretty good. I don't see anything terribly wrong with them. So the next step is to put the boards into the etchant, and we'll etch the boards and I'll bring it back in. Okay, so good news. The traces turned out pretty good. There is one break on the main board, but that's okay. I could just patch that. That's not a problem. I also tinned the boards, so that's why they look silver. Anyway, so the next step is drilling. You can see I have a drill press. So I'm going to do that now, and I'll bring it back in. Okay, so we got the circuit all prepped, ready to go. Let's build this circuit. Okay, so it's been a few days since I last touched this project. But the good news is I think I'm done. As you can see, the boards are populated. I've got all the control switches on. What else? The BNC jacks, the meter. Oh, and speaking of the meter, it has its own PC board on the back. And I've got a quick disconnect too, so instead of mounting the actual meter on the board itself, I decided, first of all, it wouldn't fit. So I decided to actually put connectors there, bullet type connectors. So it'll be really good because I can test, and then when I'm ready to put it in the actual case, that I could just, you know, drill the hole or whatever, and then slide it in, and then put that board on. So that's good. The middle board's done, and then the main board on the left is done. So, and one thing you'll notice is there's a blank PCB board on the back. So this will act as shielding. So it is connected to the ground on the actual main board and the switchboard. So there's a blank board there too. So the article requires it, so we'll go with it. And I think it was only because the case that they used was a plastic one, and this circuit is very sensitive to noise that's around the room. In fact, I was going to put it in a plastic case too, but I couldn't find one that was big enough. So I had to buy an aluminum case, but I had already done that board, and I'm just going to leave it and it'll be fine. Just extra protection, right? So anyway, the next part of the process will be testing, or trying to test the circuit and see if it works. So I'll bring you back in at that point. Okay, so I am back, and I finally have the circuit working. Now, it's a very complicated circuit in terms of operation to check the THD of an amplifier, let's say. However, it does work, I suppose. Now, I haven't hooked it up to an amplifier yet to actually test it, but the calibration went well, more or less, and I'm ready for a test. So what I'm going to do is put all of this stuff into a case, which is kind of over there. Luckily, Electronics Australia gave me a template, so I'm going to use that. Now, I'm going to have to add one more pot, only because when you are calibrating it, there was a 2K pot on the board itself. But the problem is when you change frequencies from 100 hertz to 1 kilohertz to 10 kilohertz, you have to adjust that trim pot. Well, you know, if it's inside the case, what good's that going to do for you, right? So what I did is I extended it out to this pot here. So we'll have an extra potentiometer on the case, and because there's a lot of switches and potentiometers, I'm going to have to put the power switch on the back. Yeah, so that's what I'm going to do. So hopefully this is the very last, or one of the very few last circuits that I do that has a lot of switches and potentiometers, because I ran into a lot of problems, and I don't want to go on for long because I know your time is precious, but and most of the problems were with me. So in total, I've probably spent about 2 weeks, a good solid 2 weeks. Well, you know, I shouldn't say a solid 2 weeks because I keep on getting interrupted with stuff, you know, having to drive my mother somewhere, etc., etc. So, you know, life goes on, but a good 2 weeks have been so far on this project, and it's still got more to go because I got to put it in the case. I figure another day at least. So what went wrong? Well, there was a lot of things wrong, and I wrote them down, so I'll try to go through them. So first of all, I had a wrong chip in the main board. Instead of a TL, I think it's a 5534. Instead, I had a TL071, which is wrong. And I had some wires that reversed. These two, it's an A and B switch kind of thing. I had them reversed, and I had a 750 ohm resistor on the board. It should have been 150. Oh, it was this board here. And so there's some switch 2 confusion, wherever that is. I don't even know where switch 2 is at this point. I think I'm delirious. And oh, and there's one thing that was kind of important. So on this board right over here, there was a spot for a resistor. At least it looked like a resistor. However, when you look at the schematic, it's not on there. Yet on the board, there's a spot for it. So initially, when I was going through it, I couldn't figure it out. I couldn't make heads or tails out of it. So I figured, well, maybe it's just a jumper, because on the schematic, it's just goes straight. The output of pin 6 goes straight to the next stage. So I said, okay, I'll just put a jumper. And it turns out, no, there should be a 680 ohm resistor. And I got that a little bit of information from, I don't know if it's Reddit, but there's a post on the computer. If you just type in Electronics Australia noise and distortion meter, you'll find it. Somebody else built this back in 2023 and had a lot of problems with it. But the good thing is he went through his journey. And because I was able to read his journey, that helped me out with a whole bunch of other stuff too on this project. So I'm very grateful for him. And I'll put a link in the description of that particular thread. And I had another a bad resistor. There was a broken trace I also found, and the switch. There was a different switch. There it is right there. And in fact, that was faulty. It was intermittent, so that was throwing me off too. Anyway, it's more or less ready to go. So I know I went on for a long time, but that's the journey I did, and I'm happy that it's done, because it's sometimes frustrating. Sometimes you get a little bit of success and you feel good about it, but then you get brought right back down. So, but I'm at a good point now, and I think we're ready for the case. So thanks for listening to the rant, and I'll bring you back in when I get it in the case. Okay, so I am back. I've got everything in the case, and I've got all the labeling done. Now, I have to be honest with you, I'm not that proud of this particular look. However, I'm getting a little fed up with these distortion meters, so I just want to get this project done and over with. Anyway, there's a lot of controls on this device. I obviously nobody's going to build this, but you never know. The stuff on the left, these four here are for the oscillator. So you've got the voltage for the oscillator, 2 volts, 200 millivolts, and 20 millivolts. And then you have a level. So right now I've got this set for maximum of 2 volts. That's RMS. And that's done for a reason. You'd have to read the article to figure it out, but that's going to be our maximum range. And you've got 3 frequencies, 100 hertz, 1 kilohertz, and 10 kilohertz. So that's for your THD testing. And here's the output for the oscillator, which, by the way, I've got on the scope right now. And I could change that to 1 kilohertz. And you'll notice that there's a bit of fluctuation. So what's happening there is that Wien oscillator has a lamp for the feedback, right? Well, the lamp's kind of slow, and that's why it takes a few seconds to actually lock in and be fine. And here's a 10 kilohertz, and you can see, there it is there. Pretty clean signal. In fact, you want a clean signal for this particular, for a THD analyzer, right? And so the other portion of it is related to the notch filter. So the whole idea is to notch out the signal, and whatever is left is your noise, your distortion, and then this meter circuit part here will then display it. Now, the actual, I guess it is pretty close because we got it at 0 now, but I got that from the actual article itself, the scaling, and I just basically blew it up to fit my meter and put it in there. So that's it. Anyway, so there's your input. So when we actually test an amplifier out, we're going to use that input, and there's 3 settings: THD, cal, and volts. So the first 2 are not going to be important for our testing when we're actually doing THD, but it's important to calibrate, and that's what those 2 options are. And we've just got a 0 dB and a minus 20 dB switch. Maybe that'll come into play when I actually hook up an amplifier. I'm not too sure. And in fact, I haven't even tested this out on an amplifier, but we're going to do it together and we're going to see if it works. Let me show you the inside. And there's the inside. So as you can see, tons and tons of switches. Okay, so I know this particular switch here, I only needed 1 pole. I know I've got like about 6, but I'm just reusing the parts that I have. And there's the meter and the board that's associated with the meter. And of course, then you've got your main board here with the oscillator and then the notch filter and the transformer and the power switches on the back. Oh, and there's an output too. In fact, I don't even know what it's for. I think it's going to be for our original signal. So we'll maybe check that out. Again, I haven't tested this to death. I made sure before I put it in the case that it calibrated, and it did. So we're going to find out if this thing works. Anyway, so let me bring you in. I'll set up an amplifier, and we'll see if we can read the THD. Okay, so I've got everything set up. So I've got the oscillator output going into the input of my Akai stereo. I've got it on the auxiliary, and I'm only measuring the right channel. And on the back of the Akai, from the speaker terminals, I've got it connected to a dummy load. And from that dummy load, I've got a coaxial connector coming back to the unit, and that's our input. So right now, I've actually adjusted, well, first of all, I'm at about 1/4 of the level on the volume. Not very loud, but it's, it's comfortable listening. And I've already went through all the motions of getting the lowest scale possible. So the whole idea is to actually take out the original signal and seeing what's left over. So our original signal being the oscillator. And whatever's left over, that's what we're going to measure, and that's ultimately what the noise and distortion is. And to do that, we're using a null filter. And to get our lowest reading, we got to go, well, first of all, we start at a high range, probably at the 0 or the +10 dB, or the 3 or 1. And then we adjust all these controls to get the lowest possible reading. Now, these controls are not 10-term pots. Probably should have 10-term pots because they're so sensitive. In fact, I don't even really want to touch it. I want to show you first what my reading is. And I'm all the way down to the 0.3. So if you look at the inner scale THD, and I'm at the 0.31 right now. And when you go to the meter, 0 to 3 range is where we should be reading. So I'm just a little bit below 1. Let's call it 1. So that would be 0.1 percentage. So 0.1% total harmonic distortion. So that's the reading. I can maybe get a little bit lower if I had more control on these knobs. And in fact, but before I do that, I'll just want to show you that output jack does actually connect to the scope, and we can actually see what we're notching out. So according to the article, now there's a whole bunch of stuff, you know, the article explains what you can do. Again, I'm just at the most a technician, and I just build stuff and I experiment with it and I learn how it works, but I'm not an engineer. So if I say something wrong, just let it go, because, you know, I just like building stuff and making them work and actually using some of this stuff in my lab when I build stuff, right? Anyway, so with that caveat, I think I could probably get more on the, if I had 10-term pots. But let me just go through or should I go through the motions? I don't even know if I should go through the motions. Let me just explain what I did. That's probably easier. I know this video is getting long. Is you start at a high scale, and, you know, you might be at 10, 9, or whatever, and then you adjust these 3 controls here to get a low reading. And then you just go, again, down on this frequency, or this, what do they call that? I guess the meter range switch. And you keep on adjusting, and then you go down one more, keep on adjusting until you get the lowest value. And that's what we got. So I didn't expect much distortion. Now, I don't know how accurate this is. I have nothing really professional to compare it with. But I think I'm in the ballpark, right? And what I'm going to do next is, really quickly, I'm going to crank the stereo up to it until it clips, and then we'll see what kind of reading we get, okay? So I'll bring it back in at that point. Okay, so one more test, and this is at the higher end. So I've cranked out the volume, and I'm going to set it 1 notch higher. So this is just the speaker output. So we've got some distortion there. You can see it's clipping. All right, so what I'm going to do is I'm going to take that off the scope, and I'm going to put it in our THD measuring device. And I'm going to take the output, or the CRO output from the actual meter, that thing there, onto our scope, and get that set up. There we go. And we'll talk about that in a second. But let's just go to the actual reading. A bit of a rush, only because my dummy load is getting very, very hot. So I've already adjusted it beforehand, and this is the best reading that I could get. So, yeah, so again, I adjusted these 3 controls here to get the lowest value, and I'm at the lowest value now. So if you look at the scale, it's the 30 scale, which equates to the 0 to 3 scale on the meter, and that's 30%. Well, I'm at about 12%. So right now, my stereo is outputting 12% distortion. And the resultant signal, whatever's left over, is showing on the scope, which is really nothing that you can really read or interpret. However, according to the article, there's a lot more you can do. I'm just going to turn the volume down here on this stereo because it's getting very hot. There's a lot to be said about this meter. It can do, I'm just showing you the basics, by the way. It's just getting our THD. There's a whole bunch of other stuff that I read in the article that I don't want to get into because I know this is a long video as it is. And it'll just take experience from myself to start playing around with it and understanding it. But as a basic THD meter, hey, I think we've got a winner here. I measured a very low signal, or low THD, and now I've just measured a higher THD, which you've seen on the scope. It was clipping, and we got about 12% distortion. Anyway, I think we've got a winner. I'm going to call it a day on this one. I probably spent about 2 weeks on and off to try to get this thing completed and to work. As I mentioned earlier in the rant, there was a lot that was wrong, and most of it was my fault, but some of the other stuff wasn't. Yeah, so let's just end it here. If you haven't already seen some of my other videos, please go back, check them out. And we're going to call this one a day. I'm going to put the cover on it. I'll put it on the bench, and we'll use it when we need to. And thanks for watching, and keep an eye out for the next video. Bye for now.